Hello everyone, this is another video from Easy Electric series, and today we want to learn about the SysTick timer, which is the one of the peripherals that you have inside your microcontroller. So before we start to talk about that, let's to just have a short introduction to the timer, somehow refresh our digital knowledge about the timer. So then we will actually move to talk about the SysTick timer and its registers that you need to initialize for using it. So as you can see here, if we back to our digital courses, we learn about the timer. Timer could be up counter or down counter. So if you consider the 4-bit timer, which is just able to count from 0 to 15, it is if it is the up counter. So if it's a down counter, this able to count from 15 to 0. So usually timer has the clock pulse, which is it could be sensitive to the rising age or falling age, and somehow the timer count these falling or rising age. So here consider this is our clock pulse, which is the one of the our inputs to the timer. So I show here the rising age. If this is sensitive to the rising age, it's counting each of these rising age. So that means if you are here and you're on 0, whenever you see that, it should be count 1. So then whenever it see this rising age should be 2, whenever you see this 3, and keep going. So in other words, if you have a counter, so the frequency of the clock pulse tells how fast is counter counting, right? So, and as you know, the frequency and period, this is the relationship between these two. So the period is the time interval between each counting. So the f is equal 1 divided by period. So that means if you increase the frequency of your timer, somehow the period is shorter, so the timer is counting faster. So if you make this frequency slower, so that means this actually t is bigger. So bigger period means there is a bigger time interval between two counting. So that means timer is going to be count slower. So that means with frequency of this clock, definitely you could say how fast your counter should be count. So here I put two examples. For example, if your clock pulse is 1 Hertz, what's the meaning of that? It means the time interval between counting is 1 second. If this is up counter, start from the 0, it should say 0, then wait 1 second, say 1, another 1 second, 2. In other words, the time interval between each counting in 1 second. So if your frequency is 1 over 5, so it means your period is 5 seconds. So it means the time interval between each counting is 5 seconds. So you will have 0. So then after 5 seconds, it count 1. Another 5 seconds, it should be count to the 2. Another 5 seconds should be 3. So that means definitely with this frequency of the clock pulse that you have, you are telling your timer how fast it should count. So also here you could use the timer for make the delay. So definitely whenever you say timer, okay, count from 0 to 15. If it takes 1 second between each counting, so that means if you load 15 inside your down counter, if you start to count from 50 to 0, each counting it takes 1 second, for example. So definitely it's able, if you load 15, it's actually able to make 50 minutes delay, right? It takes 50 seconds to count from 15 to 0. So definitely this is a way we make actually delay. So we should know what's the frequency of our clock pulse and what should be the time interval between each content. Then based off that, we could calculate if you want to make any delay, which number should be actually load inside the timer. So let's to have one example. This is another example. It says the frequency is 1 Hertz. So how long it takes this timer count from the 0 to 15. So definitely whenever frequency is 1, time interval between each counting should be 1 second. For counting from the 0 to 15, definitely you need to have 15 seconds. So that means the other way to make a delay is you know the frequency of your clock pulse, and you should figure out which number, if you load the number, which number you should load to your counter, and if you load that specific numbers, how long it takes it finish the counting. Somehow you forget the idea if you use the timer, how long you could actually make the delay. So here is one example. So suppose you have the counter, so it work with 100 frequency. Frequency is 100 for these down counting. You want to actually make the delay or make the delay for 1 divided by 10 second. So the question is which number I should load here, which these counter start to count from that number all the way down to the 0, and the whole of that process take 1 divided by 10 second. For answer that question, you see, okay, what is my frequency? 100. What is the time interval between each counting? The answer is 1 divided by frequency, which is 100. So which number I should load, which is start to count down from that number, I don't know. I put that X. So how long it should take? I know how long it should take. I want to actually make a delay for 1 divided by 10. So that means the time interval between each counting time to the number that you load. So it should be 1 divided by 10 second. So what should be the x from this equation? The x is 10. So that means if I load the number 10 inside the down counting counter, so it takes 1 divided by 10 second. This counter actually count down from 10 to 0, right? So because you say 10, 10 times each time interval between each counting is 1 divided by 100, so that means totally you need 1 over 10. So that means in SysTick timer usually we figure out which number we should actually put inside that counter, which make the specific time delay that we need. So these kind of the calculation you will see in SysTick timer, because technically we are going to use the timer to count the time for us, and we are able to make any time delay that we want. So this is actually is the basic knowledge that you should have about the counter. Let you move to the SysTick timer. So as I mentioned before, the SysTick timer is one of the peripherals that we have inside the Cortex M4 microcontroller. So here you see it is a down counting timer. So here I'm going to review the most important registers that we have for SysTick timer, which we need to initialize them that able to use these timer. So again, this info is in the datasheet. You could go and check the PDF file of the Launchpad and find the same info that I put here. But what I try to do here, I try to that make more simple and just summarize the important part of that. So instead of the reading that few page PDF, here I summarize the important things that you need to know. So in general, the SysTick timer has three important registers: CTRL, reload, and the current. So the CTRL register is, as usual, is the 32-bit register. So we just manipulate the bit 0, 1, 2, and 16, which is the most important bit that you have inside this register. So let's start with the bit 0 in CTRL register. So bit 0 somehow is an enable bit. It's actually turn the timer on and off. If you want to turn that on, write 1 here. If you want to turn off, you put the 0 here. Okay, simple. So bit number one in CTRL register, we call that it is the interrupt enable bit. If you want to use the interrupt with your SysTick timer, so definitely you should enable that. Writing 1 here, enable the interrupt, writing a 0, disable interrupt. What is the interrupt? Interrupt is the advanced concept in microcontroller, which is not the topic of this video. I hope I get or have enough time that I'm able to record that topics, but for now just CTRL bit number one, you just able to enable and disable the interrupt. If you don't use the interrupt, just write the 0 here. So bit number two is the clock selection register. So writing 1, it says you are going to use the bus clock or the clock source, which is the 16 megahertz. So writing the 1 there, it tells you are using the bus clock and your frequency will be 60 megahertz if you don't use the phase lock loop. So if you don't use the PLL, what is the PLL? PLL is another peripherals which you are able to use it to change the frequency of your microcontroller. I'm going to record the video for that in uh, in uh, in next few days. But for now, just know writing 1 here, it keeps the input, the main source of the SysTick timer is 60 megahertz. But if you use the sorry, not this one, we are talking about this. So if you actually use the PLL, definitely you could get the any multiplication of that 16 megahertz. We will talk about that later on. So usually we write 101 here. So that means if I write 101 here, what I'm telling I enable the timer. 0 here means I am not going to use the interrupt, and 1 here is my main clock source is the 16 megahertz that I have on the launchpad. So the next important bit here is the flag bit, bit 16. So these flag bits get set every time the counter rolls over. So that means if you load 500 in your counter, it start to count from 500 to the 0. Whenever you get the 0, so it is actually will be 1 for a short time, then actually back to the 0. So that means with checking these flag, you know, okay, you actually count 1 times and you are going to start the second round. Very important bit that we are going to use. So the next important register, SysTick timer register, is reload. So again, it is 32 bits, but you just could use bit 0 to 23. It's clear that from the name, it's actually you could load any value that you want inside this reload. So that means if I load 500, so the SysTick timer start to 100, go all the way down. 1000 start to counting 1000 all the way down to the 0. So whatever you put here is start to count down from that number. Again, just be careful. You couldn't actually write 32 bits on that. So 0 to 23 is the 24 bits that you could initialize any load value on it. So the current is the next one. The current register again is useful bit is 0 to 23, totally 24 bits. And usually it shows the current value of the counter. So that means if I upload 500, so in that time you see the 500 here. Then it's moved to the 499, you see 409 here. Then 498, you see the 498. So that means whatever is your current value in your SysTick timer, you could actually see that value inside the current register. So a few comment here. So as I mentioned before, the SysTick timer is the down counter. Okay. So whenever it goes to the 0, it will be set the flag and then reload back to the value from the reload register. So that means whatever you put here, if you put here 50, it start to count down from 50, 49, 48 all the way down to the zero. Whenever it's actually go down one time, it's active these flat, set these flag bit, then again back to count from the 50. So the other thing is what is the bus clock? So as I mentioned, if you don't use the PLL, put one here, put one here. It uses the 16 megahertz bus clock. So it means what should be the time interval between each is counting? The answer is 1 divided by frequency. So if your frequency is 16 megahertz, so it should be 62.5 nanoseconds. So that means the time interval between each counting is 62.5 nanosecond. So that's actually the other things that you need to consider. How set up the SysTick timer? It's easy. First, you should turn off the SysTick timer device. So whenever you configure it, so then by setting, yeah, you could actually deactive, then you active that. So that means with writing one, it should be deactive. Then after writing one, it should be active. Okay. So then you need to load initial value to the reload. Whatever you want to count down, you put that value inside the reload. And then you need to set up some value in the current. Usually you put the zero on that. So then at the end, what you should have on the CTRL101. So again, back to these 3 bits. So I somehow explained this, writing 101 here. So 1 means you enable the clock. Here 0 means you actually don't use the interrupt. And 1 here you say that it use the bus clock, which is 16 megahertz. That's what you see usually you write here. So it is again summarize the same thing, right? This is 101 in the CTRL. So if you want to count from 5,000 to whole way down, write that here. And usually current value should be 0. Then whenever it start go down, it shows the current value that you have. Just give you one example. If I wrote the 5,000, so it should start to count 5,000 whole way down to the 0. So what should be the time interval between each counting? So the frequency is 60 megahertz. The answer is 1 divided by 60 megahertz. So that means the time interval between each counting should be 62.5 nanosecond. Whenever it is all the way down 1, and whenever it's small, it's moved from 1 to 0, which somehow means you count one time, you are going to start to counting down for a second time. So in that time, the flag set, which is these bits 16 in CTRL, it should be 1. So somehow you know with checking that flag bit, you actually know you are done with counting or not. If you want to measure any time interval, it is easy. If you have these two numbers, so last and now, you just subtract these two, how long it takes from this number to this number. The answer is the period, which is 62.5 nanoseconds. So if you times that with these two numbers, you get actually time interval between each counting that you have. So that means you have one base, which is somehow exactly you could measure the time. You could have the track of the time based off seeing what how it the counter move from value that counting now from the previous values. We are going to check that in the codes that we are going to write. So this is actually the basic knowledge that you should have about the SysTick timer. So we are going to have one example. Probably I'm going to record the video that show you how you could use the PLL and SysTick timer for making the delay, for keeping the LED on and off for any time interval that you want. So, but for now, let's do just in this video, I'm more focused on the register and give you idea about the SysTick timer, how it works, and how you should initialize the register for using that. So definitely in the future video, I give you one example. You will see exactly the application of them. So for now, let's do check again, focus on the register, somehow implement the same thing, the all basic knowledge that we learn here, and implement them with the codes. So number one is the number of the register that you should use. So in the launchpad, these are the name of the register. So NVICCTCTRL is the register that I mentioned as a CTRL. That's actually the complete name you could see on the code. So again, this is its address. We use define to somehow just have the access to the register just with name, not using the address. So this is actually the reload register. This is its address. This is actually the current register, and this is address. Definitely you should have this in beginning of your code if you want to use the SysTick timer. So we talk about how you could initialize the SysTick timer. We mentioned you should actually turn that off and then turn that on, then able to you are using to use the SysTick timer. So that's what you should have the function like this. Here you see the VUID SysTick init, which is getting no input and it's return no data time. So what it's you write the 0 here on the CTRL. So what it means, if I write the 0 on this, so definitely this enable bit is 0. That means I turn off the timer. So then you write actually 5. What is the 5 is 0, 1, 0, 1. So that means this is exactly the same thing that I explained here. This is a 5. With writing 0x05, so you are writing 010 in CTRL. So what you did, you turn that on again. So you say interrupt is 0, and you are telling the input of the timer is going to be 60 megahertz, the boss clock that we have. Okay. So that's what you actually have these initialized. Definitely you should have something like this which initialize your SysTick timer. So that means after this, your SysTick timer is ready to use. So let's see how we could use that. So definitely, as I mentioned, we use the SysTick timer to have it tracked of the time and make a delay. So let's see. We make actually one function we call the SysTick timer wait. So its input is just the number we got just count. So let's see how these SysTick wait function work. So you actually put whatever you have as input inside this reload. So if I put count, it should be start count from count -1. So you reload these number inside the reload register. So that means if you put 500 here, so definitely the register start to count down from 500 to actually 0. So the reason is this is count 1 because you count from that number to the 0. Technically you should start with count -1, right? So if I put 500, technically I'm counting from 499 to the 0, right? So that's the reason you see count number 1. So then you put the 0 inside the current value and see what's the meaning of this. You say while this CTRL and this bit pattern. See this bit pattern. This is first is hexadecimal number. So each of these 0 is 4-bit. I'm going to convert this to the binary and see what's happened here inside these parentheses. So you are ending the CTR register with this bit pattern. This is the 40, this is 40, this is 40, this is 40. So that means here to here, technically you have 16 0. We should be start with the bit 0 to 15. So that means bit 0 to 15 is 0. So bit 16 is 1 and the rest is still 0. So let's see if I AND the CTR register with this. Somehow I'm take a look to the which variable. So I'm technically and these bit 16 with the 1 and the rest count with the and with the 0. So that means I'm somehow see or checking these bit 16 because I and that with 1 and the rest and with 0. All of them will be 0. The only things actually I get is these bit 16. So that means these and that you see here technically show me the bit 16 in the CTL register. So if it is 0, so that means this is true. So you actually you should actually wait to be 1. So that means the only case you are going to see, it says bit 16. So you actually say you say while this open and close, and definitely you should have the curly bracket here. So that means what happened in this, you are checking bit 16 and waiting for bit 16. So that means the timer start to count, right? So start to counting from whatever you load. So then it's count all the way down, and you will be out of this function whenever your flag actually is set, right? So then you will be out of this while loop. So that means somehow this function wait all the time until you finish your counting. If you put 500, it's actually wait until you finish 500. So you could be actually go out of this function and do the other things that you have. So in other words, so let's see if I put anything here, how long it takes to counting. So here, suppose your frequency is 80 megahertz. This is just assumption, okay? If I use the PLL, I set up the frequency to 18 megahertz. So what should be the time interval between each counting? It should be 1 divided by 80 megahertz. 1 divided by 80 megahertz is 12.5 nanoseconds. So that means the time interval between each counting is 12.5 nanoseconds. Whatever I put here, if I put 500, how long it takes it finish these 500? The answer is 500 times these number. Okay. So now see the second function. It's claimed this is the function that able to take 200 millisecond delay. It could actually make 200 millisecond delay. Let's see why. So it is just simple for loop. So then inside the for loop, it just says actually SysTick weight this number, which is 6 million. So SysTick weight, here is the definition of the SysTick weight. So if your count is 16 million and your frequency is 80 megahertz, so let's see how long it takes it finish counting 16 million. So each time interval between each counting is 12.5 nanosecond, which is 1 divided by your frequency, right? So if you put 16 million, how long it takes, it counts down from 16 million to 0. So the answer is 16 million time each period or time interval that you have, which is 12.5 nanosecond. 16 million time 12.5 nanosecond is 200 millisecond. So that means this function making 200 millisecond, but you put that inside the for loop. So that means you could make any multiplication of these 200. If I put 5, so it means I'm making 5 times 200 milli. If I put 1, because this is a for loop, right? So each inside this for loop takes 200 millisecond, right? So how many times you repeat that depend on the 10. If you depend on the t. If you t is 10, you repeat this 10 times, and each loop takes 200 milliseconds. So that means you could make any multiplication of 200 millisecond. That's the reason you see this is 200 millisecond. So depending on your need, you just change the 10, and 10 times this will be the time delay that you make. How about this? Let's turn off the LED, turn the LED off for 2 seconds, and then turn that off for another 2 seconds. So let's see what we have inside the main. So you write the data register these numbers 0x02. What is the 0x02? 2 is 0120. Technically you are writing 1 on a PF1, right? So you turn on the PF1. So then you call this function, but instead of the t, you put 10 milliseconds. So if I put 10 here, what's happened? If you repeat this for loop 10 times and each loop takes 200 milliseconds. So if I repeat that 10 times, should be 10 times 200 millisecond, which is 2000 millisecond. It should be 2 seconds. So that means this is exactly take actually 2 seconds to finish whatever we declare. So I turn that on. So I wait actually 2 seconds, then I turn, this should be actually 0. So then I write 0x0, which means I turn off the PF1, and how much I keep these in this condition again, another 2 seconds. So if you put these inside the loop, there is no loop here, but you could put the loop. So that means somehow you turn this on, wait for 2 seconds, then turn off, wait for another 2 seconds. So that means you turn the LED on for 2 seconds and turn that off for 2 seconds, which is very accurate because the SysTick timer technically you are able to use SysTick timer and PLL, and you are able to make any accurate time interval that you want. So this is somehow give you idea about the SysTick timer, how it works. So as I mentioned, in the next video, I'm going to actually record the video. It should be the lab assignment. You will see how you could use the SysTick timer and PLL, which is you will see the same codes there. It gives you actually more idea how we could use that. So in here, I just want to give you a basic knowledge of the SysTick timer and how you could use that to make the delay. I hope you find this video useful. Thank you for watching this video.